A motorboat starts from rest on a lake accelerating in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? So the question is this: we have a water body, and then we have a boat on this, which happens to be a fast boat. I mean, not fast boat, motorboat, speedboat. May not be speedboat, right? Anyways, it has a motor basically, something like this, and you have a person standing over there. Okay, now he or she starts from here and goes to this point. It seems they start from rest. That's what I marked. So rest means what? Your initial velocity is, yes, and it's been accelerated. So A is equal to 3 meter per second square for a time period of 8 seconds. So that is your time period. And now we have given u, which is equal to 0 meter per second. Then we have acceleration, which is 3 meter per second square, and time period. Right, nothing to convert over here, simple and straightforward. Time period is also given, 8 seconds. And we have the unknown quantity, that is S is equal to what? Now we have the working. So we have S is equal to ut plus half into at square. So that would be equal to u is 0 plus half into acceleration here is 3 into time is 8 into 8. Alright, it looks bad. 1s are 4s are 12, 5 is 62, 72, 96. So 96 meters. Is it not? So that is the distance, how far the boat travels. That's the distance that the boat has traveled. So let's see this as a simulated manner, with a simulated manner. Okay. So how do you do that? Go to this program, change the initial velocity, which is 0. I already changed, and the acceleration. So all these are in meters. This is in meter per second, and this is in meter per second square. So we have to start the simulation, and here, okay, enter the command. F stands for going forward. So it takes into account the acceleration. So that was the first second, second, third, fourth, fifth, sixth, seventh, eighth. And now after 8 seconds, right? Then enter something like T to terminate. So if you terminate this, here it won't make much sense. So you can see it is accelerating. That's the only thing which we can be sure of. The graph would answer remaining things. So example over here. See, at 8 seconds, look at what is the distance that the vehicle has traveled. So if you're not able to pinpoint over here, you can always look over here. See, it'll come up over there. Can you see that? 8 seconds, approximately 96. Of course, there is variation because I'm moving it up and down. So if I exactly point over there, then you'll get an answer. So approximately we got 96 over there because I'm not able to pinpoint. You can zoom in and do that actually. I won't do all of that. You guys can do that. So this is your answer. Okay, and you should be always trying to figure out the answer graphically also. You can see here the distance is increasing non-linear fashion. That means the velocity is increasing. So in this case, velocity happens to be linear. Thus, the acceleration is a line which is parallel to x-axis. That is a constant uniform acceleration. So this is what you have in your syllabus. The last toughest scenario is this for you guys. So you need to understand how the distance, displacement, velocity, and acceleration looks. right? So if you keep doing that with every problem from now onwards, if I show or don't show, doesn't matter. You guys have to learn and understand. Okay, so this is important, and everything else is just a matter of calculation.